what you made me do. Look what you made me do. Look what you just made me do. Look what you just made me ooh.
Oh, hey guys. Sorry, just listening to my T Swift. What's up? We're gonna do some math right now. I hope you liked my intro. I hope it hooked you. These are our notes for day 3, radical expressions, adding and subtracting radicals. So there are a few steps. The first step when you add or subtract radical expressions is to simplify each radical individually. Oops, okay. So we want to simplify each radical individually. Okay, and then keep in mind that you can only combine like terms. You can only combine like terms. So like terms means same index. And, this is key, same expression under the index. I'm clearly not like well versed in this. Sorry guys, this app is a new update, so I'm not kind of like used to this, so this is choppy. Oh well. Okay, so same index, and then this is key. It needs to be the same expression under the radical. Okay, so here's our notes. We got to simplify individually, then combine like terms, which means same index and same expression under the radical. So first example, here we go. Notice that these are like terms. The reason why these are like terms is because we have the same index and the same expression under the radical. Same index, same expression under the radical. So, think of this as like a 1x plus 6x. My answer would be 7x. Well, guess what? There's an invisible 1 in front of this radical. You literally just add the coefficients. We have a 7 cube root of 5x squared. And I'm done. Let's try the next one. Now for this one, I do have to simplify each individual radical, and then I can add if I have like terms. So for example, I can split up 18. 18 is 9 times 2. And if I square root each of these, square root of 9 is 3 root 2. Now with this 4, this is a multiplication problem. So 4 times 3 is 12 root 2. And I kind of just forgot about that k. There's a k under all of these. Okay, so this is my first expression. Let's go to the next one. 72 can be split up. It's 36 times 2. Square root, we have a 6 root 2, and the k stays underneath with the 2. And it is a minus, so minus 6 root 2k. Next, 50k. So break up the 50, it's 25 times 2, square root. Square root of 25 is 5, root 2, and the k stays under the root with the 2. And this is a positive. Okay, guys, take a look. I have now all the same like terms. So my final answer is just going to be adding the coefficients. So 12 minus 6 is 6, plus 5 is 11. So my final answer is 11 square root of 2k. And let's go on. So there's nothing I can do with this first radical. I can't reduce that at all. So we're good there, but I can reduce the second one. Keep in mind that this is cube roots this time. So we need to find a perfect cube that goes into 32, and that perfect cube is 8. 8 times 4 is 32. Now cube root these. The cube root of 8 is 2. The cube root of 4 I cannot do, and obviously this x, I cannot cube root it. So I have a 4x underneath my cube root. Now, with this 5, again, I'm multiplying. So right now I have just this original cube root of 4x minus a 10 cube root of 4x. And lastly, we are going to look for a perfect square that goes into 108. I'm not a perfect square, a perfect cube. So that's going to be 27. 27 times 4 is 108, and I can cube root 27. That's why it's a perfect cube. I get 3 cube root of 4, and this x cannot be cube rooted, so it stays underneath. Don't forget to multiply by 2. And 2 times 3 gives me a 6. This is a plus 6 times the cube root of 4x. All right, now just add up your coefficients. This is an invisible 1. So we have 1 minus 10, which is negative 9, plus 6, which is negative 3. So I have a negative 3 times the cube root of 4x, and that's my answer. And we're going to move on. Okay, I love this problem because I'm done. There's absolutely nothing I can do. These are not like terms because I have a different expression underneath the radical. My answer is just 3 root 15 minus 3 root 11. You cannot combine these at all in any way. I'm done. It was a trick question. Moving on. All right, so for this one, the instructions say to multiply. So to do that, what I like to do is first multiply the outsides. Then multiply your insides. And obviously, at the end, you're going to reduce. All right, so let's do this first example right here. Multiplying the two outsides. That's 3 times 2y. That's going to give me a 6y. Now multiply your insides. We have 6 times 9, which is 54, x to the third, y to the second. Okay, now I'm just going to reduce. So I need to find a perfect cube. The reason why it's a cube is because the index is 3. That goes into 54, and that's 27. So that's 27 times 2. And I can cube root x to the third. So I have an x to the third and a y to the second. Now I just cube root everything. Cube root of 27 is 3. I cannot cube root 2. So that stays inside. Cube root of x cubed is x. And then I cannot cube root the y squared. And now I just have to multiply the outsides together one more time. 6 times 3 is 18. I have my x, I have a y, and then I have a cube root of 2y squared. And that's the answer, guys. All right, this next example looks scary. We're going to be okay. There's a trick to this one. So first, just multiply your numerator. And to multiply the numerator, we just multiply the insides. So right here, I have the cube root of 16, m to the fourth, n to the third, over, I'm just rewriting the denominator. So the cube root of 32, m to the fourth, n to the third. Now this looks scary, but yesterday when we were splitting up our radicals, you can actually go backwards. So since they're both cube roots, we can just rewrite this as one big cube root. So this is one big cube root of 16 m to the fourth n cubed over 32 m to the fourth n cubed. And the really cool thing that happens is that the m to the fourths cancel and the n to the other thing that happens is that 16 over 32 reduces to 1/2. So I have the cube root of 1/2. Okay, but now I have to split it back up. So this is the cube root of 1 over the cube root of 2. Okay, well, the cube root of 1 is 1. So I have 1 over the cube root of 2. And then just like yesterday, we do have to rationalize. So 1 over the cube root of 2. To rationalize this, I need 2 more 2's to make a 3 of a kind. So what I get is, on top I just get the cube root of 2 squared, which is the cube root of 4, over the cube root, now this is 2 to the third. So my final answer is the cube root of 4 over 2. Wow. That's the answer, guys. Whew, okay, let's move on. All right, this one is fun. So this says simplify. What I'm going to do is reduce all these radicals in the denominators. Now, I cannot reduce the first thing, the first cube root of 2. So I am going to reduce the second one, though, because 8 is a perfect cube, and 8 times 2 is 16. So let's cube root both of these. And that gives me cube root of 8 is 2 times the cube root of 2. Next, 54 is 27 times 2. So now cube root those. And I get 3 cube root of 2. Okay. So here's what we've got. I'm going to rewrite my problem. 5 over the cube root of 2 minus 2 over 2 cube root 2 plus 1 over 3 times the cube root of 2. Now, in the second fraction, those 2's can cancel. Just a little FYI. So I'm going to rewrite this again without that numerator of a 2. Now, I do need a common denominator, and the common denominator is just 3 root 2, which means I need to multiply these by 3. Five times 3 is going to give me a 15, minus 1 times 3, which is 3, plus 1, all over my common denominator, which is 3 cube root of 2. Okay, 15 minus 3, and then plus 1 gives me 13. 15 minus 3 is 12, plus 1 is 13. Over 3 cube root of 2, and now just rationalize. So I have to make a 3 of a kind. Okay, so I get 13 times the cube root, 2 squared is 4, over, here I have 3 times the cube root of 2 to the third. Well, the cube root of 2 to the third is 2, and 3 times 2 is 6. That's my final answer, you guys. Whew, okay, we have one more thing to talk about, and then we're going to call it a day. Here's the problem. Okay, so I realize this video is very long, and so therefore I'm only going to do this one example, and we will talk about this more on Monday. All right, so this is rationalizing the denominator when I have a binomial. So binomial means this, 5 minus root 3. So I cannot just multiply by root 3 over root 3. It doesn't work that way. What you need to do is multiply by something called the conjugate. So by the conjugate. Okay, so what do? Well, the conjugate, you just change this middle sign. So whatever this middle sign is, you just change it. So like this, minus, it's going to change to a plus. Okay, so I'm going to multiply my denominator by 5 plus root 3. Don't overthink this, you guys. In my numerator, I'm going to just distribute the root 2. So I get 5 times root 2. Root 2 times root 3, just multiply the insides, we get root 6. I cannot combine those because root 2 and root 6 are not like terms, so I'm done with my numerator. Now in the denominator, you all are going to love this. You have to FOIL. So we are going to multiply 5 times 5, which is 25. 5 times root 3 is plus 5 root 3. Negative root 3 times 5 is minus 5 root 3. And then root 3 times root 3 is root 9. Square root of 9 is 3. And then it is a negative times a positive, so it's minus 3. Now, this is fun because the 5 root 3's cancel, and we just get 25 minus 3, which is 22 in the denominator. Remember, the goal when you rationalize is to get rid of the radical in the bottom, which is what we just did. This is my answer. Okay, so you need to practice this conjugate thing. I know I'm only going over one example, but you can actually look at my notes on Schoology and look at that last example, okay? And you can try to figure it out from there. I'm also posting the answer key to worksheet 2, which is your homework for the weekend. Thanks for watching, you guys. Have a great weekend, and I will see you on Monday.